Hi, so now to continue, I'm going to be answering question 3 for the Unit 4 assessment. So, my question for question 3 was for the given function, determine and discuss the following features if they exist. Domain and range, intercepts, and behavior, first and second derivative, intervals of increase and decrease, maximum and minimum values, intervals of concavity, inflection points. And the function I was given was f of x is equal to x plus 1 cubed times x minus 2, which is also known as x to the power 4 plus x cubed minus 3x squared minus 5x minus 2. So I decided to start off by determining the domain and range. So the domain would be x is equal to any real number because the function I was given is a polynomial. And next I decided to go on to the intercepts. So to solve for the x-intercept, I decided to use the factored form of the function, because which is the x plus 1 cubed x minus 2, because I thought that would be easiest for solving for intercepts. So I took both of the brackets and I solved for what x would be to allow that bracket to equal 0. And I ended up getting -1 and 2, sorry. So that means that the x-intercepts are -1, 0, and 2, 0. Next, for the y-intercepts, I plugged in 0 as the x values to the original function, so to the longer function, and I solved and ended up getting -2, which means that the y-intercept, is 0, -2. The next thing I decided to determine were the end behaviors. So I knew that by plugging in a really large number as x to the original equation, if I end up getting a number even larger than that, or a very large number in that case, that means that the limit as x approaches infinity would be infinity. And same goes for the as x approaches negative infinity, which you can see here. I plugged in a large negative number and or a very small negative number, depends on how you kind of look at it. And I ended up getting that both of these, when plugging in both of these values into the equation, I ended up getting a very large positive number, which meant that as x, the limit of f of x as x approaches infinity and the limit of f of x as x approaches negative infinity were both infinity. Next, I took a look at the derivatives. So by using the exponent rules and the rules you'd use when looking at derivatives, I ended up getting that the first derivative was 4x cubed, which I got by moving the 4 down in front of the x and subtracting 1 from the exponent, plus 3x squared, which I got by doing the same thing, minus 6x, which I got by doing the same thing, minus 5, because the minus 2 in the original equation would leave, since that's one of the rules. And then the second derivative, by doing the same rules, I ended up getting that the second derivative is f second prime of x is equal to 12x squared plus 6x minus 6. So since I had now solved for the first derivative, I was able to solve for the intervals of increase and decrease. So I took the first derivative, which is 4x cubed plus 3x squared minus 6x minus 5, and I solved using a quadratic formula, and ended up getting the first x to be 1.25 and x2 to be -1. So I plugged those into my first derivative chart, and when I plugged in values greater or lower or in between the two critical numbers I found, I ended up getting that when f prime of x, when f of x is going to be a number smaller than -1, it's going to be decreasing. When it's going to be a number in between -1 and 1.25, it's going to be decreasing, and when it's a number greater than 1.25, it's going to be increasing. So I knew that since f of x was going from decreasing to increasing at 1.25, that's the local minimum. And since there was a decreasing to decreasing at -1, that initiated to me that there might be, or there will be, a point of inflection there, but I saved that for later when solving for the point of inflections. So I ended up then plugging in 1.25 into my original f of x equation and solving for the y value, which ended up giving me -8.5. And that was my local minimum, because when going from a decreasing to an increasing in a graph, that is when you have a local minimum. So next is my concavity and my point of inflections. So I used the second derivative for this, and I solved by factoring basically to x1 and x2, which ended up being 0.5 and -1. So when I used my second derivative chart, I saw that at -1, before -1, the original function was, the original function was concave up. In between -1 and 0.5, it was concave down, and after 0.5 was concave up. So as you can see, we go from concave up to concave down to concave up, which means there are 2 point of inflections. And to solve for those two, I ended up basically plugging in my values, so -1 and 0, and then I also ended up plugging in, -1 into the equation, which ended up giving me -1, 0 for the point of inflection and the points with the y values included. And then I ended up plugging in 0.5 as well, which ended up giving me a y value of -5.06. And in the end, when I took all of these points together, I went into Desmos and I put in the graph. And as you can see, I have a x-intercept and a point of inflection at -1, 0, and I highlighted that there. I have a y-intercept at 0, -2, which I highlighted there. I have an x-intercept at 2, 0, which I highlighted there, and I have a local minimum at 1.25, -8.5, which I highlighted there. And as you can see, I was correct when stating that the function will be going towards infinity as when the function is approaching infinity or approaching negative infinity. And lastly, just a challenge I wanted to go over, or a problem, is here I ended up finding when doing my work that there was a point of inflection, here at -5.06 and at -0.5, so 0.55, -5.06. And I believe that I made a mistake in my first derivative chart where the values prior to -1 should have been concave down, meaning there wouldn't have been a point of inflection. But when I plugged into my calculator, I kept getting positive values, so I'm unsure of what went wrong there. But yeah, that's just something I want to go over, because when I looked at my graph, that there was no point of inflection there. In fact, there was no point at all there. So yeah, that is my answers for question 3 for the Unit 4 assessment.